Hello, ladies and gentlemen, and fellow aviators. I offer a series of lectures on general aviation safety and often accident analysis on general aviation incidents and accidents, which is usually just my opinion. This lecture today focuses on engine failure during and after takeoff, where we discuss some of the causes uh, causing these accidents and how to avoid this situation, sometimes with pre-flights and other type of planning. And then also we cover what to do when it happens to you. And the name of this PowerPoint and my paper is called The Unreasonable Turn. I'd like to take a second to introduce myself. My name is Will Rondeau. I'm an aviation career professional. I was born and raised in an aviation family, and as a young man and teenager, I worked on a line crew where we gassed up and oiled aircraft, cleaned them, towed them, and stuff ramp kind of work. Then by the time I went into college as a freshman, I had my ground instructor's license. And by the second semester of my freshman year, I had my CFI license where I actually instructed at the airport where I went to college. Then after college, I started my commercial career. I flew for a charter company, both as co-pilot and captain on Beechcraft Barons, Beechcraft Queen Airs, and also some Piper Navajos. And then after that, I went to work for some corporate Fortune 500 flight departments for a little while. And after that, I left for the airlines where I ended up flying for 4 airlines for the rest of my career. As far as my education goes, I have an Associate's of Science degree in professional piloting and airport management, a Bachelor's of Science in business administration, and more recently, after retirement, I have a Master's of Science degree in aerospace safety management and security. So after 50 plus years of flying, I received the FAA Wright Brothers Master Pilot Award, and I'm also a safety team representative. All accidents and incidents in aircraft have causes. Accidents don't just happen, and there's always reasons for them that we usually find during accident investigations, of which I've done quite a few accident investigations in my career. This aircraft we're looking at right here looked like it had an engine failure on takeoff, landed in an area where it was a survivable crash, and so these people are lucky to get out of that aircraft. So what we're going to look at here in this PowerPoint lecture today is the causes of crashes, what we can do to possibly avoid them, and again, what do we do when it happens to us. This graph right here is from the National Transportation Safety Board, the NTSB, and this chart shows the total number of general aviation accidents for the 10-year period from 2009 to 2018. The blue bars shows the total number of accidents for each of those years, and the yellow bar shows the total number of fatal accidents. Not the number of fatalities, but the number of accidents that had fatal accidents. These numbers that we're looking at in general aviation have been consistent for many decades. General aviation has suffered between 1,200 and 1,400 serious incidents and accidents for many decades. I believe it's still going on today. And unless we make changes, we're still going to see these kind of accidents in the future in general aviation. Let's take a closer look at some of the NTSB leading causes of accidents and incidents in general aviation for the year 2018. The big number we see across the top is our landing accidents, and it's the largest number with about 440 and very few fatal accidents in this category. The next one is the en route phase. There's approximately 220 incidents and accidents at about a 30% fatality rate. These typically include loss of control in flight, flying VFR into IFR conditions where the pilot loses control of the aircraft. And we also see some of these accidents in some of the practice areas that pilots are in. The next category is maneuvering, with about 150 crashes at a 44% mortality rate. Typically, these are accidents that are in the traffic pattern, aircraft turning downwind to base and base to final, and often sometimes departing and losing control of the aircraft right after takeoff. The next category is takeoff, where we see 160 of these at about a 10% mortality rate. We're going to cover some of those in our lecture today. The next one is the approach phase that showed 140 at about a 38% fatal rate. And again, these are quite often instrument approaches where pilots flew them incorrectly, went below minimums, or lost control of the aircraft on missed approaches type of crashes. And the final one we're going to talk about right now are the initial climb. There's 133 of them, but a very high mortality rate, the highest at 46%. And this is some of the information we're going to cover in our lecture today about takeoff and losing an engine after takeoff and the mortality rate and how we can avoid these kinds of crashes. So now as we look at what I call scenario number one, this is called an engine failure on takeoff with a turn back. However, there's three areas to look at in the turn back. And as we look at the graph on the right, we see a green, an orange, and a red arc. These are three different types of turnbacks, and we're going to cover them in detail in this lecture. So this first one is a return to airport that we're seeing in the green arc, where the pilot loses an engine at 300 or 400 feet above the ground, where you see that the aircraft there. And then the pilots are making a turn back to the airport. The green arc is a standard rate turn, and so here's how this kind of plays out, these accidents. When a pilot loses an engine on takeoff, it's a startling event. And research shows us that the awareness takes 3 to 6 seconds for a pilot to start to realize what happened and to make a decision. So this is where I tell you to stay cool, take a deep breath, and start to make a decision. Now, the first thing we do, we lower the nose of the aircraft and obtain VBG, or best glide airspeed, and then trim the aircraft. Now, the pilot rolls into a standard rate turn here in the first arc, the green arc. 180-degree turn at a standard rate takes 60 seconds. And as we look at the graph where that line is there, the horizontal line is where the aircraft would roll out. So a standard rate turn would have an aircraft roll out approximately 4,480 feet from the end of the runway. That's 3/4 of a mile. Then the aircraft has to make a 45-degree turn back in towards the runway, and that chews up approximately 15 more seconds of flying time. And then as the aircraft gets closer to the runway, they need to make another 15 or 20-degree, in this case a left turn, to align with the runway, which shows a total of 75 to 78 seconds of maneuvering or more, and an approximate altitude loss of 1,250 feet minimum. So as we look at the next slide, we'll look at some of these figures and how important they are. So this is the FAA's best glide speed, which takes into account distance and time, and at its best glide speed. So let's go back to the standard rate turn again. Let's look into that a little more closely. The standard rate turn, and we're going to use 70 knots here. We're using Cessna 172, where in clean configuration would have a stall speed of approximately 65 knots. So what we're using here is maneuvering at 70 knots for our calculations. So a standard rate turn would be approximately a 12-degree bank. Again, we're looking at a lateral displacement after the 180-degree turn of 4,480 feet with a time of 75 to 78 seconds and an altitude loss of 1,250 feet. Now, the second or orange arc we're looking at shows 2 times the standard rate turn. So 2 times the standard rate turn would be a bank angle of approximately 24 degrees. And now our best glide speed is 74 knots, because increasing the angle of bank also increases the stall speed, and that would be VSO. The lateral displacement for a 2 times standard rate turn is about 2,240 feet from the end of the runway at a time of 38 to 40 seconds with an altitude loss of approximately 875 feet. Now, the red arc that we saw shows the pilot turning into a 4 times standard rate turn, which would give us a bank angle of 45 to 48 degrees. We also have to increase the airspeed to 78 knots to maintain our maneuvering speed over VSO. At the end of the turn, lateral displacement is approximately 1,120 feet. And since he's so much closer to the airport, the pilot only has to make a 10-degree correction to get over to the runway. And again, we have that 3 or 4 seconds to align with the runway. So what we see is a lateral displacement of 1,120 feet in a time of 15 to 17 seconds and an altitude loss of approximately 526 feet. To me, this is doable for a return to the airport, however, only at higher altitude. And the graph that we saw showed the pilot at about 300 or 400 feet. So none of these things would be doable for an emergency landing at 300 or 400 feet. So no pilot would really make after engine failure a turn at a standard rate. And we use that just for comparison to show the differences between the different rates of turns. Every one of us, after an engine failure after takeoff, would probably rack the airplane into a steep turn, obviously left or right. And this creates a much larger problem for the pilot. Quite often the pilot is trying to find out what happened. He's rolling into a turn, and that gets these pilots caught up at what we call the fatal stall and spin, which is not a good scenario to be in. Now let's look at this next scenario here. This is scenario number 2. So now we're going to skip over the 2 times return, but we're going to go to the 4 times standard rate turn now. Again, the pilot rolls into a 45 or 48 degree bank. Increases stall speed. So I have 20%, so that gives us the maneuvering speed of 78 knots. The timing in the turn, and plus the 10-degree turn, is approximately 16 seconds, and it shows an altitude loss of 526 feet. This one is most doable, but it's also very dangerous, and the higher you are above the ground, the more doable this would be to return to the airport. But to make this happen for any pilot, he or she has to be on their best game and has to have a fair amount of luck to make this work to actually get back to the runway. Let's look at scenario 3 now, which I consider is probably the best scenario to do for engine failure after takeoff. So the engine quits, you lower the nose immediately, and you get your glide airspeed. Now you have about a 60-degree area, 30 degrees left, or 30 degrees to the right of the nose of the flight path to make your decision on where you're going to go. You're going to obtain your best glide airspeed, and you'll trim the aircraft for that. And you can get your best glide airspeed typically out of your pilot operating handbook. And again, we're using the speeds for the Cessna 172, which is typical for single engine airplanes. Look for that landing area. Start to maneuver the aircraft toward the landing area to align with the area you're going to crash land in. Now, if time permits, you're at a higher altitude, and time permits, let's check the fuel system. Look down at the fuel selector handle. If it's off, we know what the problem is. Turn it to one of the tanks that has fuel in it. Look over at the mixture control. Sometimes they come out and that could cause the engine to quit. And also take a quick look down at the magnetos, make sure they're in the both position. Now, if it appears you're not going to get the engine going, turn around and brief the passengers, tell them to brace for impact. And then prepare the aircraft for your crash landing. And to do this, I recommend you open one of the doors. Now, when you do this, you may increase the stall speed by a few knots, but what you're really going to notice is the noise level in the aircraft once you open the door. So when an aircraft crash lands, quite often the fuselage twists, and you want to be able to get a door open, and this will give you that ahead of time before the crash. When you're getting ready to crash, keep the wings level. Maintain an airspeed of VSO or VS1, that's clean or dirty airspeed, plus 5 knots. And again, with this crash landing, good luck with that. Now let's go over to this turn rate versus time. Again, the standard rate turn of 12 degrees, we're going to use up 75 plus seconds to make that turn back. At 2 times, we have a 24-degree bank angle, and we're going to use up 35 plus seconds. And again, at the 4 times turn rate, we're going to use up 16 seconds. But again, that puts us in that area where the pilot can roll the aircraft over, stall it, and spin. We want to avoid that. So according to the FAA, the best glide airspeed versus distance and altitude, and they say that for every 1.5 miles flown, the aircraft loses about 1,000 feet of altitude. And that is in a no-wind condition. And also you must consider on a turn back to the airport, what are the airport conditions? Is there more traffic over there? Would turning back to the airport be a good decision or not? And let's look at these causes that pilots can run across for emergency landings. So the first one, of course, would be engine failure. You're going to obviously have an emergency landing after that. Or the engine not developing takeoff power. If you don't feel that on the runway and the aircraft is sluggish in the air, you might just have that problem. Another one is smoke or fire in the cabin. This is very distracting and a very dangerous situation. And in this one, you're definitely going to land as soon as possible wherever you can put the aircraft down. An engine fire is a possibility. Now, an engine fire, you're probably not going to see the flames in the aircraft. Typically, it's under the fuselage, but you'll smell the fire. And again, that's a good time to get the aircraft on the ground right away. The next one that's very dangerous is electrical fire and smoke. This smoke typically comes out from under the instrument panel, which is right in front of the pilot, and this is also very distracting. And this is another one where you're going to be landing pretty quickly. There's only one thing you could really do is turn the master switch off, and that would cut the power to many of the instruments, and that may stop the smoke, but you're still going to be landing pretty quickly. The next one is oil on the windshield. If you have a constant speed propeller on your aircraft, this could be an indication that the seal that controls the propeller pitch is leaking, and that will put oil on the windshield. And that's a good reason to return to the airport also. On that one, though, you could probably turn downwind and land on the runway. This next one is very distracting, but it's not really an emergency. It's something that could be handled very easily, but it has also caused crashes on takeoff. And this would be a passenger door or baggage door opening. It distracts the pilot, it's noisy, and the best thing to do here again is turn downwind, go back and land. If you have to declare an emergency, do it. And once you get back on the ground, close the door, and then you'll be good for takeoff again. The last category that I can see here is after takeoff, you strike another aircraft. It could be just at liftoff on the taxiway or whatever, but your aircraft is still flying. So is this going to be a crash landing straight ahead, or you can be able to turn around or fly downwind? That's a decision you'll have to make at that time. Also, what we've seen in airplanes is we collide with birds. We hit birds on climb out. Something new today are the drones. We have to be aware that either the bird or the drone can come through the cockpit window or windshield and that can be very dangerous and also distracting. Another one I've seen over the years is pilots will climb out. They're probably a little lower than they should be, and they go through the top of a tree. But the airplane seems to be running okay. Well, it's not okay. This is a time for you to turn around and land, go back to the airport, and see just what happened to your aircraft. Now, let's look at the three choices any pilot can make once they take off and they have some kind of an emergency after takeoff. The first one that I recommend the most is crash land straight ahead within 60 degrees of the aircraft nose or flight path. Pick out a place where you look you can put it, where it looks like you can put it down, and head for that area. Then as you climb a little higher, and we'll discuss those shortly, you'll be able to make a 45 to 90 degree turn to look for a place to crash land, but not really turn around for the runway. And the last one would be fly downwind, declare an emergency, land on your departure runway or any other runway. And this would be used for the door opening, oil on the windshield, things like that, where you can get back to the airport and land on the runway that you took off from. Now let's look at this altitude, distance, time, and topography decisions, I call it. So you're taking off as you're climbing out from the runway level to 700 feet above the ground. I would say that an engine failure or some other kind of dire emergency, you're going to crash land straight ahead. You won't be able to make any turns up to 700 feet. Then I'd say from 700 to 1,000 feet above the ground, now you have the option of making a 45 to maybe a 90 degree turn to head for an area where you can crash land, probably safer. The next phase we're going to go through here would be the 1,000 to 1,500 feet above the ground, where you could consider that turn back to the runway. But again, you need to know your options and what they are prior to takeoff, like the wind, again, the traffic pattern at the airport, how busy is it, and be prepared. Always be prepared for a engine failure on takeoff. And a point I'd like to make here about pre-flighting and planning for an aircraft is the best safety decisions for any flight are made on the ground prior to engine start. And that's an indication that you've done all your homework prior to going flying. Now this chart we're going to look at here, many of you have already seen this in your pilot operating handbook. It's a comparison for the angle of bank versus stall speed. So that would be clean VSO or dirty with flaps and gear down or VS1 stall speeds, typical for most general aviation aircraft. So as you look at these numbers, you can come up with ideas of what you would need to do if you took off and had some kind of emergency or emergency at altitude. What would be your air speeds to glide down at, and how far could you go? This would be helpful in knowing that. Now let's look at some of the preventive measures to keep this kind of accidents from happening. I know most of you are not going to agree with me or kind of laugh at it. That's fine, but my point here is don't do your own maintenance. Sure, it's okay if you need to blow a tire up or strut or do something minor like that. That's okay to do. But for any other kind of maintenance, that's what we have mechanics for. And a lot of the stuff you may do on your own could be illegal if the FAA, if you had an accident and the FAA catches that, you could have some kind of violation from the FAA on that. The next one is keep accurate maintenance records in your logbook. Let's say a tire goes flat, probably not so much for that, but if something simple like a tie down hook is broken or something, put it in the logbook, get it replaced, have the mechanic sign it off so you have a record of really the health of your aircraft throughout the years that you have it. The next one is your regular maintenance inspections. The annual is a must. Depending on what kind of flying you're doing, the 100-hour check is a must. These are laws, and it's very important to have your aircraft inspected when it's supposed to be. The next one is hangar your aircraft. I know hangars are not available quite often. I see that around the country. Guys complain about it, and I hear guys complaining about the cost also. But If your aircraft is sitting outside in the heat, the cold, the wind, the rain, the snow, the ice, whether it's covered or not, it's really not good for your aircraft and the aircraft system. So if you can hangar your aircraft, I highly suggest you do that. The next one is fly your aircraft and do some practicing. When you fly your aircraft and you take off, do a couple touch and goes, go out to the practice area, do some stalls, steep turns, do some of that stuff. It's good for you and it's good for the aircraft systems to be working. The next one is practice engine failure procedures. So go out to your practice area, climb to altitude, pull the power back, and get your glide airspeed and descend at your glide airspeed and see approximately how much altitude you lose in 30 seconds or 60 seconds probably. And then do the same thing again, climb back up and do it at a 30-degree bank and again at a 45 or 60-degree bank. And since you're flying the airplane, if you have a buddy to go along with you who can make notes, that's going to give you an idea of how far you're going to be able to glide your aircraft with engine failure. And you can also try this with some 180-degree turn back. So that's always good practice to have that in your mind. So the day that you do lose your engine on takeoff, you've already got this information and know how to fly the aircraft. The next thing is know your speeds, your best glide airspeed and your best lift over drag airspeed, typically from your pilot's handbook. But where you're not going to see these speeds is going to be on your colored airspeed indicator. These speeds are not indicated on there. This is something you're actually going to need to know. This next one is very important. This probably causes more fatal crashes than almost anything else in general aviation. And it's knowing the actual weight of your aircraft. If you're taking some buddies out flying, you ask them how much they weigh and they tell you, well, they weigh 180 pounds, and you look at them and you go, you're not 180 pounds, you're 200 or 220. Did you throw a set of golf clubs in the baggage compartment? 1 or 2 sets of golf clubs. So I've gone and weighed golf clubs to see how much they are. So golf clubs are approximately 45 to 50 pounds per bag. So when you're throwing those in a baggage compartment, that could easily overweight the aircraft and make it out of balance. So my point here is do not overload your aircraft. Always do your weight and balance so you know what you've got. Now, how to avoid some of these emergencies prior to takeoff. When you're walking out of the FBO to go flying and you see your aircraft at a distance, this is a good time to start looking your aircraft over. How does it look from a distance? Is there anything hanging off of it? How's it tied down? Just a general consensus of what your aircraft is looking like. As we get up to the aircraft, either before or during or after your pre-flight check, check the fuel. We're checking for water contamination. It's typical that you will get some water contamination if your aircraft has been sitting very long, or if you just fueled up an hour or so ago. Sometimes you could have some fuel some water in the fuel. So we know how to drain those tanks, but look for water contamination and make sure that you get all the water out. Another thing I've run across is the color and the smell of fuel. We've run across aircraft that were fueled with jet fuel when they were supposed to have 100 octane. Now we know the color of 100 octane is green and we expect that. But jet fuel is clear and it also has a different smell to it. So check your fuel and know what kind of fuel you have in there. Visually check your fuel levels, whether you have a high wing aircraft or a low wing aircraft. Open up the fuel tank, look inside to just get an idea of how much fuel you have in there. And then when you get in the aircraft and turn on the master switch, make sure that your gauges are corresponding to approximately what you saw out there in the tank. Check the oil level. You need to check the oil level before every flight. Go out there, check the oil level, and replace the oil cap yourself. Make sure that cap is properly installed, because losing your cap and in flight, you will be losing oil from your engine. It's not a good idea. So next we're going to look at the fuel selector. When you get in the aircraft, look down at the fuel selector. It should never be in the off position as far as I'm concerned for single engine aircraft. But if you're renting an airplane or a flight school, a flying club, something like that, and they turn the fuel tank off after landing, that's not a good idea, and something that you need to talk about and change with the other pilots who use that aircraft. So my thing here is put the fuel selector on the fullest tank, the one that you saw out on the wing, and also the one that shows the fullest in when you turn the master switch on. Select the fullest tank, and on that tank, start the engine, taxi, run up, and take off on this tank. That eliminates one big cause of engine failure after takeoff. Now, as you do your before takeoff checklist, I know you're going to check that your fuel pressure switch is on. You will have checked the magnetos, make sure the engine's running smoothly. You glance over and check the engine instruments, that they're all in the green. And I've noticed pilots have missed in the past that the oil pressure will be in the green, but on occasion they'll start their takeoff run with the oil temperature not in the green. This is not a good idea for the longevity of your aircraft engine, and it's just not a good operating practice. And the next one is your takeoff power check. When you come up with power for takeoff and you take a quick glance over at the engine instruments, again, they're all in the green. They're not going moving back and forth as if something could be wrong. How does the acceleration feel of your aircraft? How is it feeling? If it's not feeling right in what you're expecting for your takeoff roll, abort the takeoff, and don't tell yourself, well, I'll check what's going on when I land. That is never a good idea. Something I'd like to input here is the takeoff emergency checklist. I believe that every takeoff checklist or pre-takeoff checklist, on the bottom, the last thing should say in large words, takeoff emergency. And this gives the pilot a moment to pause and think about, yes, what do I do if I have an engine failure after takeoff? It gives you the mental picture where you can think about at what altitude if you lose an engine, you're gonna turn, where you're gonna go, do you know the topography? I think this is very important, and I would like to see this change for all general aviation aircraft. It would certainly cut down on some of our accidents. Then the next thing I'd like to talk about in here is your initial climb. We all like to make smooth takeoffs, and that's fine, but I believe we should right after takeoff, we should climb at VX, or your best angle of climb airspeed, so we get the most altitude over the distance covered. And then at about 1,000 feet above the ground, you can transition to VY, or your best rate of climb. And I think that's just a good operating practice and a good thing to do. This next slide we're looking at now tells us what to do when an engine fails after liftoff. First, again, be prepared. So the engine fails, be proactive. Hopefully you've known the topography, you know just which area you can go to. And as you're climbing out, go through those phases up to 400 feet straight ahead. 400 to 700 feet, I can make a turn. 700 to 1,000 feet, go through those phases as you climb out, and that'll give you more ideas as you're climbing out. You're thinking about what you can do as you climb out, and these are very safe practices. Again, if you lose the engine, lower the nose, get that and trim the aircraft for your best glide. If it looks like you can't return to the airport, tell the passengers brace for impact, open that cabin door. The stall speed may increase, but the noise level will definitely increase, and you will not be able to communicate with anybody after that time. Now, I recommend that sometime you're flying in the pattern, nice day, and you're downwind, I recommend you open one of the cabin doors just to see what it looks like and feels like. So the day it does happen to you on engine failure, you know what to expect. Don't push the door out. A door that opens like that will typically just fare into the slipstream, and it may cause an increase of stall speed, but not very much. So as you're approaching your crash landing area, have the wings level. Have your airspeed at VSO or VS1 plus 5 knots. And in this area, keep your nose up, maintain your airspeed, and don't let the nose drop here. And during the crash landing, try to crash so the landing gear and wings absorb the initial impact. Quite often, the fuselage will twist after landing, and if you had opened the doors, you'll have egress from the airplane after you crash land. And then after landing, if you can turn the fuel pump off or just get out of the airplane, exit the aircraft as quickly as possible, gather with the other people upwind of the aircraft, so when and if it catches on fire, the smoke and flames will be downwind of you. Now, after this happens, you have up to 10 days to file your accident report with the NTSB and keep a copy of that. Now, let's talk about a few common sense things here. Anytime you have an emergency in an airplane, the first thing to do is stay cool. Take a deep breath or two and decide what you have. When you're down low, act decisively. Make that plan and stick with it. So if you're climbing out and your engine fails and you see a place you want to land off to the left and you start a turn over there, then all of a sudden you see a place off to the right, I suggest you just stay with your original plan. You're losing altitude and airspeed and turns. Stick with the plan that you've come up with. And be prepared. Tell yourself on every takeoff that you're going to have an engine failure. And again, that engine failure emergency takeoff checklist will always prime you to think about, yes, I could lose an engine on this takeoff, and be prepared for that. The next thing is practice. Practice your gliding, your airspeed, your distance, feel of the aircraft with the engine throttle back and descending. Those are very important things to do. But what I think is the most important thing for a pilot to do is fly your aircraft. Fly as much as you can. If you're out on a good day, you take off. Again, do some takeoffs and landings. Go to the practice area. Do some cross countries. Come back and practice. This is the best thing a pilot can do to maintain, your currency. And again, let's remember this. This is very important. The safest decisions for any flight are made on the ground prior to engine start. So that terminates our PowerPoint today on engine failure after takeoff. So if you need to contact me, if you're interested in seeing other PowerPoint lectures that I have posted, other general aviation safety subjects on YouTube, and I may be contacted through my website, captainwillrondeau.com. If you want to schedule an in-person lecture or ask me a question, if you wish to view my newsletters that I offer every month, that's also on my website. Or if you have a comment on any of the information I have put out there, please let me know. Now, again, fly safely. I hope to see you all out on the flight line, and thanks for your time. Good day.